Our next program is to write an ALP to convert hex to BCD and BCD to hex. So this is the section.data. We have declared the menu here, defined it, and these are the messages. This is the section.bss where we are gonna declare the variables and it's how much byte they are. The buffer is of 6 bytes. The digit count is of 1 byte. The answer is of 1 word, and char answer is of 4 bytes. These are the macros to print, read and exit. Now this is our section.text where our main program is there. The first instruction is to call the macro and print the menu. Then the second macro is to ask user the choice what she wants to operation to do. So buffer is of 2 because 1 byte is for buffer, 1 byte is for choice and 1 for enter. Now we'll move this contents of buffer into the AL register. Only the lower byte we are gonna move into AL register. Now we'll compare AL with different choices. If it is 1, then jump to hex to BCD procedure. If it is 2, then to BCD to hex. And if it is 3, it will go to error message and then go to exit. Now first is hex to BCD conversion. We'll ask the user to enter 4-digit hex number. So to do that, we'll call the procedure accept 16. 16 means for hexadecimal, because it has base of 16. Now we will read using macro. The buffer length is equals to 5 because 4 is the total number of digits which we are gonna read characters, and 1 is for the enter key. We'll XOR the BX, so it will be 0. We'll put the count equals to number of digits, that is 4, and then put it into the counter register, that is RCX. Now we'll point the RSI to the buffer variable. These are the instruction, exactly same how we convert ASCII to hex. I have explained it before in my basic video. So if it is we'll first compare AL to 0. If it is below than that, and go to error. If not, then check for this. We'll compare to 9. If it is below that, we'll subtract sub 30, and similarly the other conditions for 37 and 30. After that we are done, we'll add the content of AX into the BX, increment RSI for the next digit by 1 byte, then again loop this to the label next digit unless and until the counter becomes 0, and then we return to the procedure where we have called it. After return, BX will contain the digits in hex, and then we'll move that into the AX register. We'll move 10 into RBX, then we'll XOR the RDX register so it becomes 0. Then we divide RX by RBX. Now RX contains the accepted hexadecimal number from the user. So when we divide RX by RBX, the quotient is kept in the RX and the remainder is put into RDX. We'll push the remainder one by one onto the stack. We'll push it DX onto the stack, which is the remainder. Increment the byte if RX is 0. If RX is 0, then we will not, if it is not equal to that, we will go to this back procedure again, and again XOR the RDX, divide. So 1 by 1 each hexadecimal number is divided by 10 and put on to the stack. So starting from the lower byte of the total digits, for example 4789, it's not a hexadecimal appropriately, because we can, it is a case of that. ABCD is not there. If you want, we can put it that also, but it will be easy to explain. So we'll first divide this. This is the content of RX register at this moment. So we'll first divide it by 10. The remainder is 9. Then again divide by 10. The remainder is 8. Then again, then 7, then 4. So the top of the stack will first be 4. So as you know, it is the last digit, but this will be popped first. So after the RX register is 0, we'll print this message, B message, equivalent BCD number is, we'll first pop DX. Now when we divide by 10, the value is 4. Now in the actual register, it will be in ASCII value, so we have to again add 30H, so that it becomes again a hexadecimal. For example, if the contents of DL is suppose A, we have divided it by 10, so our remainder will be 0. Now when our remainder will be 0, it will be in the ASCII format of this hexadecimal chart. The answer will be this. So we need to add 30H, so it points to 0 with ASCII value having 48. That's why we are adding 30H into that. Now move this DL into the char answer variable and then print this char answer on the display. So it will print only one digit that time. Now we'll decrement the digit count, and if it is not equal to 0, then again print to BCD. While we were pushing the remainder onto the stack, we were incrementing the digit count one by one. So that's where digit count came. So after it has printed the decimal, so our next option is convert from BCD to hex. In this, we'll first ask user to enter 5-digit BCD number. Now buffer length equals to 6, 5 for digits and 1 for enter, and the buffer is name is buff. So another, now we'll point RSI to the buffer variable and XOR RX register, which will make it 0. Move 10 into RBX and 5 into RCX, which is the count of the digits. Now first we'll XOR the RDX register, so it will be 0. Now we multiply EBX, and by default it is multiplied by RX, in which RX contains the lower byte and lower significant byte, and RDX contains the higher significant byte. Now we will XOR the RDX, which will make it 0. Now buffer is RSI is pointing to the buffer. That value, that means the current digit which entered in the BCD format. Now we'll put DL into that and then subtract 30H from that, so it can be converted into the hexadecimal form. After that, we are adding the contents of RAX and RDX register. After this step, we'll increment the RSI register to by 1 byte to point to the second character of the buffer, which means that is the second digit. We'll decrement the counter. If the counter is not 0, we'll again jump to this back one procedure and repeat it until the counter is 0. Now we'll get the final result into the AX. This we will put into the ANS variable. So then we'll print this message, H message, which is equivalent hex number is this, and then we will call display 16 procedure. Now we have to start it from the most significant byte to the least significant byte. So that's why the first pointing RSI to the char answer plus third byte. Count is 4, the total number of digits. We'll make RDX 0, move 16 into RBX, divide RAX by RBX. So and then compare. So remainder will be in the DL. So now we'll compare it with the 09H. If it is below that we'll add 30H. If it is greater than that, we'll add 7H, then again 30H. Then we'll move this content of DL into the buffer pointing by RSI. That means the char answer. We'll decrement the RSI and decrement the count. Now since we started from the most significant byte, we want to move to the least significant byte. That's why we are decrementing the RSI register. After decrement count is, unless and until the count is not 0, this loop will repeat and print the digits one by one. So now we will see how it is implemented. Now we will select the first option, hex to BCD. We'll enter the 4-digit hex number A, B, C, D. The answer is 43981. Now we want BCD to hex 981. So this is the same hex number or the BCD number we have entered. So if you like this video, please like it and subscribe it. Thank you.